Hello students, good morning to all of you. Today we are going to discuss about another important concept in current electricity. That is the grouping cells, grouping of cells. This is the ninth part. In the eighth part I have given what is EMF, what is internal resistance, what is terminal potential difference. So what are the Kirchhoff laws? Two laws I have given. Right, so grouping cells is based on Kirchhoff laws only. If you remember Kirchhoff laws clearly, the grouping cells are very easy. Are you clear? So that purpose on again one more time I have given. So Kirchhoff voltage law. What is Kirchhoff voltage law here? The total potential is in the closed loop is the change in potential. The change in potential in the closed loop is zero. Is zero. Correct? Right. So for cell purpose, my path I select here positive to negative, higher potential to lower potential. My path is like that I consider. Right, higher to lower, change in potential is equal to negative. Change in potential is equal to negative. Similarly, my path I took there negative to positive. Negative to that will lower to higher. So in this direction, that is the so delta V is equal to positive. Delta V is equal to positive. Similarly, for resistors, this is the direction of current. This is my path. Okay, my selecting path. Both are in same direction. In that case, I will consider as a negative. Delta V is a negative. Similarly, here, so this is the current path, is the my selecting path, my assumed path, closed path. Alright, so both are in opposite direction. Opposite direction mean positive. Opposite direction mean positive. Same direction mean negative. Same direction mean negative. Opposite direction mean positive. Right? Okay. Right. So now grouping of cells. What is that? Grouping of cells. There are three types will be there. There are three types are there. One is cells in series combination, and second is cells in parallel combination, and cells in mixed grouping of cells. Cells in mixed grouping. So these two questions are very important for PU purpose. This is a little bit competitive purpose. Okay, this is a competitive related question, this one. But these two questions are very important for PU purpose and problems purpose also. This is the entrance exam purpose. This is the most competitive exam for CET or mains and NEET purpose. Very important. This is the concept. Cells in mixed grouping of cells. But PU purpose, cells in series combination, cells are in parallel combination. Are you clear? Okay. So first one is that cells in series. Cells in series. Cells in series mean we will consider two cells or three cells. We should connect in series combination. Correct? Right. First derivation, this is the just 3 mark question only. Very important. This is a 3 mark question. So consider two cells of EMFs E1 and E2, or else epsilon 1 and epsilon 2. Anything you can take, no problem. But I took there E1 and E2. Right? Consider two cells of EMFs E1 and E2, and their internal resistance R1 and R2. Internal resistance is how much? R1 and R2. Internal resistance is R1 and R2 are connected in series between the points A and C. Right. So now I will consider here. So two cells I will consider. First cell, positive terminal and negative terminal. Right, here this cell EMF is equal to E1. This cell internal resistance is equal to R1, or else I can draw separately. This is the R1. Similarly, second cell, same polarity, not reverse polarity. Reverse polarity also later I will give you. So this is the EMF is equal to E2. Its internal resistance is R2. Right, this is the point A, and this is the point B, and this is the point C. Like that will be there. Okay, equivalent resistance will come in this manner between A and C. Equivalent resistance is equal to E equivalent. So R equivalent. The current is moved from positive terminal to negative terminal. Okay, positive to negative charging cell only. So in this manner we will consider. Right. So now I want to calculate first potential difference. This is the first terminal, this is the second terminal. Okay, terminal A, terminal B, and terminal B, terminal C. The potential difference, terminals only, na? That means that is the terminal potential difference. Terminal potential difference. Okay, so the terminal potential difference between A and B, that is for first cell. For first cell, terminal potential difference between A and B. Alright, so that I will write here terminal potential difference. We can represent it as VAB. So difference VA minus VB. You know from the terminal potential difference formula, what is that? V minus I, V is equal to E minus I into R. Correct formula? Terminal potential difference formula. Previous also I told very clearly in the session 8th. Yes or no? In the part 8 also I have given terminal potential difference, very important for solving series combination or parallel combination like that only. Right? So VA minus VB is equal to here potential EMF is equal to what? E1 minus I into R. Current is same in series combination. Current is same in series combination. Correct? Right. So VAB is equal to VA minus VB is equal to E1 minus IR1. That is the first one over. Next one, the terminal potential difference between B and C. That is the for second cell. For second cell. Right? Second cell. Right. Same one. What is that? VBC is equal to VB minus VC is equal to E2 minus I into R2. Correct? Is I will give equation number 1 is the equation number 2. So now we can add it to 1 plus 2. I will do 1 plus directly. Okay, 1 plus 2 or else. So AC, VA minus VC. VA minus VC we can write VA minus VB plus VB minus VC. Like that also will come, but directly I will do. So 1 plus 2. 1 plus 2. Therefore, what would be happen here? So, or else you can do it potential, the terminal potential difference between A and C. A and C. Then what happened here? VAC is equal to VA minus VC. Na? VA minus VC. That is I've written. So VA minus VB plus VB minus VC. Any objection here? No more objection, right? Minus B plus B get cancelled. Therefore, answer is the same only. Therefore, VA minus VB is equal to this one only, right? VA minus VB. How much? E1 minus I into R1 plus VB minus VC. E2 minus I into R2. Therefore, E1 terms write together plus E2 plus and minus take common minus I. Therefore, what will come? R1 plus R2. This is the VAC for this one. Finish. Similarly, for equivalent resistance, equivalent cell, not a resistance, equivalent cell, terminal potential difference, this one. So current is same only I. Therefore, formula what is that? AC, right? VAC. VAC is equal to VA minus VA minus VC. So directly I will write here. So what is that? Equivalent resistance how much here? E equivalent minus I into R equivalent. This is the equation number 4 and this is the 3. Alright, once you can observe there. Equation 3 and equation 4. From equation 3 and equation 4, we can write it that resultant. Right? Okay. So, from 3 and 4, LHS both are equal. Correct? Now we can equate RHS. So, E equivalent is equal to E1 plus E2 and minus minus and I. Therefore, R equivalent is equal to R1 plus R2. So, from 3 and 4 we can equate RHS. What is that? This one, comparison. From 3 and 4 we can compare VAC, this one and this one. Therefore, E equivalent is equal to E1 plus E2 and R equivalent is equal to R1 plus R2. This is our answer. E equivalent as well as R equivalent is equal to how much? E equivalent is equal to how much? R1 plus R2. R equivalent is equal to R1 plus R2. This is the answer. Finish, man. This is a 3-mark question. Alright? Okay. Small note. What is that? For n cells. For n cells are there. All are having different EMF. Then E equivalent is equal to how much? So 2 is there mean E1 plus 2, E2. N is there mean what would be happen? So up to N only na? E1 plus E2 plus so on En. Why? Because just sum only. Correct? Similarly, R equivalent. So R1 plus R2 plus so on Rn. Right? So now for cells, n identical cells connected in series combination. Therefore, E equivalent is equal to E plus so on how many times? N times. Correct? So that how many E's are there? N. Each resistor, each cell EMF is equal to E. So, very important formula this one. Identical equivalent cell for N. Again, identical cells are there connected in series combination. So, E equivalent is equal to N into E. Similarly, for R, okay, N identical cells are there. Identical cells. Then R equivalent is equal to R plus so on R. How many times? N times. Correct? Therefore, R equivalent is equal to N into R. Very important formula this one. Right? EMF. E equivalent is equal to N into E. R equivalent to N into R. For resistor also same, right? For resistors, R is equal to N into R. EMF also N into E. This is the series combination. One method I have given. Here I did not use any Kirchhoff laws. Correct? I did not use any Kirchhoff laws. Directly I used with the help of a terminal potential difference. The potential difference between two terminals is known as terminal potential difference. So that VAB is equal to VA minus VB, this and all. Alright. Now I can apply Kirchhoff laws. How can we solve with help of Kirchhoff law? How can we solve this this derivation? Right, same derivation I will give you, see that. With help of Kirchhoff law. Very easy that is. So now I will consider just 2 points only enough. I will consider here 2 points. Is the A and B. Okay, A and B. Now here very important path only, right? Very important path. I will consider path is in this direction. This is my path. Where to where? higher to, this is the higher, this is the lower, plus and minus. This one also plus and minus. Higher to lower. Correct? This is the path. Is where to where? Higher to lower. Therefore, delta V we will consider as a higher to lower, positive. Correct? Positive we will consider. Right, ma. So at this point, potential is how much? VA. Right? So now my current is moving this way. My way is moving like that. Higher to lower. Higher to lower plus 1 in that. So plus E1. Next resistance will be there. Resistance. Current direction is which? This direction. My path direction opposite to. So current is same direction mean negative. So opposite direction mean plus. So that how much current will be there? Plus I. Resistance is R1. Right? Okay. Next here. This one more cell will be there. What is that? E2. Higher to lower, right? E2. Higher to lower mean positive. Next here, what is that? So plus. Correct? Is the plus. Extremely sorry here. There is both are same direction mean what is that? Negative plus. So correct one. Oh, I done mistake my here. Higher to lower. Higher to lower is negative, right? Oh, sorry. Here this is the minus. Okay, here also what will come? Minus. No more. Extremely sorry, Nana. Higher to lower. Higher to lower mean negative. Higher to lower mean negative. Plus this one. This is opposite mean plus only, right? What is that? I into R2 is equal to, at this point, potential is VB. Potential is VB. Correct? So now this VB take that side, this and now you can transfer to that side. Therefore, VA, before that, here minus take common. So E1 plus E2 and plus I, R1 plus R2 is equal to VB. Now this one take this side. VA minus VB is equal to, is the minus becomes plus only, right? E1 plus E2 plus minus, this the plus is becomes minus. Minus I into R1 plus R2. Correct? Finish? How many steps? Only 3 steps. But in examination, you can follow first step only, first process only. Is a 3-mark question, right? That is why. So VA minus VB is the terminal potential difference. Here also you can compare this one. So here also what is that? Is going in this direction. So how much here? This is the at point A, VA, right? This is the minus E equivalent plus I into R equivalent is equal to VB. So take this side, VA minus VB. The transfer that side, E equivalent minus I into R equivalent. Equation number 2. This equation number 3. So from 3 and 2, 2 and 3. Okay, is a 2 and 3. Both are equal. Again here same only. 3 and 4. Right here I will give you 2 and 3. So VA minus VB, we can equate. And comparison, E equal is equal to E1 plus E2 minus I, R equal is equal to this one. Are you clear? This is with the help of, so Kirchhoff law, Kirchhoff rules is a series combination. Series combination finish. So next, for example, sir, these cells are connected in reverse process. Connected in reverse process in this manner. Then what would be happen? This is the, can I rub? Yes, I can rub this one. Right, polarity is a changed. One battery polarity is a changed. Right? Okay, I can write here from here onwards. So 1 second. Right, next one is, what is that? Cells in series opposition. Series opposition are if polarity of any cell is reversed. Polarity of any cell is reversed. For example, here two cells are there. For example, internal resistance and series reversed. Series opposition. Polarity is reversed. Polarity is reversed. This is the E1 and this is the R1. This is the E2. Here resistance is R2. Is the B point. This is the A point. Is the R2. This is the higher and lower. This is the lower and higher. Now I will consider my path is in this manner. Okay. Any path, any direction can take, no problem. If I take from here to mean, first this will come. If I take this one, first will come this one, VA will come. If I take from here onwards, VB, higher potential. Correct or not? Higher potential to lower potential, like that only. Right. So in this manner will be there. So now you can observe Kirchhoff law. According to Kirchhoff law, this is the VA. At A, potential is VA. Right. Higher to lower. Higher to lower is negative minus E1. Are you clear? Then this one, current is going in the direction only. This is the I and I. So what is that? Opposite. Opposite means plus. Plus I into R1. Next here, lower to higher. Remember, lower to higher. Where is that? Lower to higher. Lower to higher means positive. So plus E2. Plus E2. Are you clear? Then this one plus I into R2 is equal to VB. Right? So now here VA minus, take common, E1 minus E2 plus I take common R1 plus R2 is equal to VB. Now VB transfer this side, therefore VA minus VB is equal to, so E1 minus E2. E2 minus I into R1 plus R2. This is the formula. Therefore, E equivalent is equal to, therefore, E equivalent is equal to E1 minus E2. But R equivalent does not change. R1 plus R2. Are you clear? So direct form you can remember. E2 is the reverse. Reversed battery we will consider as a negative. For example, here how many cells are there? So first cell and second cell and third cell is the reversed. Third cell is the reverse. This is the A and this is the B. So this is the E1 is the E2. This is the E3 and R1, R2 and here R3. Then E equivalent is equal to how much? Same direct formula. What is that? E1 plus E2 minus E3, right? This is the reverse. For example, this is reverse, A minus will come. That's it. Right? So that's it. Next, R equivalent does not change. R1 plus R2 plus R3. R1 plus R2 plus R3. Okay? Small problem based on that. So what is that? So if battery E1 and internal resistance and battery and internal resistance. Okay, so right, so here one problem I have given is the E1 is equal to 10 volt, E2 is equal to 2 volt. Okay, so now this is, I will consider 4 volt reverse battery. Is a reverse battery. Internal resistance 1 ohm, 1 ohm, 1 ohm only. Then equivalent resistance is equal to how much? R equivalent to so equal EMF is equal to, equal resistance is equal to how much? That is our question. Alright, so that you know E equivalent formula. What is the equivalent formula in series combination? Is the E1 plus E2, but this is the reverse polarity, therefore E3. Similarly, R equivalent is equal to R1 plus R2 plus R3. So 1 plus 1 plus 1 is equal to 3 ohms. E1 10 volt. Okay, this is the 2 volt minus 4 volt. That is equal to how much? So 6. Yeah, how much will come here? 2 minus 2. Here 8 volts. E equivalent is equal to 8 volts. Are you clear? This is the problem. So small doubt also will come, sir. For example, this path you can take it in this direction, sir. Then what would be happen? Then what would be happen in the first case as well as second case? In the first case as well as second case. Same only, value does not change. First case this one only, na? Yes or no? So first case. Now I will give that one also answer. So now my path I select from where to where? B to A. B to A. So B to A. So this is the lower, this is the higher. Right? My path is this direction. So I can start from here. So VB. Okay? So then current and resistance. Current and my path both in same direction, minus only, na? So what is that? I into R2. Lower to higher. Lower to higher is the positive. Correct? Lower to higher is the positive. So what will come here? This is the E2. So plus E2. Right? Next again minus I into R1. So lower to higher. So plus E1 is equal to VA. I want to VA. So now I want to potential difference VA and VB. So that VA minus VB is equal to E1 plus E2. Same only, na? E1 plus E2. Minus side, take common. R1 plus R2, same only, equal. That does not change, right? Any direction you can take, no problem. Similarly, second case. What is the second case? So this is the battery and reverse polarity. Reverse polarity, this is the A and is the B, is the E2 and E1, R1 and R2. So now path is, I took from B to A. B to A. So start from here only, na? So this is the current direction. This is the I and I and I. Okay. So start from VB. VB. This is the higher. This is the lower. This is the lower. This is the higher. Correct? Then higher to lower. Higher to lower is the negative. Is the negative. So minus E2. Now current. So extremely sorry. First this one, right? Both are same direction, minus I into R2. Next minus E2. Then minus I into R1. Lower to higher. Lower to higher is the positive. So plus E2 is equal to VA. Is equal to VA. VA you can transfer that side. VB transfer that side. Therefore what happened? VA minus VB is equal to, so this is the E1, right? Is the E1. This is the E2. Correct? Lower to higher. Lower to higher is the positive, right? Okay. Lower to higher, positive. Oh, sorry. Here E2. E2, this is the E1. Higher to lower. Higher to lower is the negative. Which one? E2. Next, lower to higher. Lower to higher is the positive. So E1 is the positive. Then, so E1 minus E2. Same only formula. A minus I take common. Therefore R1 plus R2. Any direction you can take, nothing will happen. VA minus VB is equal to E1 minus E2 into minus I of R1 plus R2. Are you clear, ma? This is the cells are in series combination. Cells in series combination. Right? Okay. Right. So next, the third one. The third concept also in the cells are in series combination only. In the cells are series combination, first question I have given, what is the equivalent resistance, internal resistance as well as equivalent EMF. Is the first question I have given. Second question, so cell opposing series. That means, so polarity, any cell polarity is changed. That is the second question I have given. Now third one is, for example, n cells are there. How many cells? N cells are there. We are connecting the series combination only. But by mistake, what would be happen? M cells are connected in opposing order. The polarity is changed. As well as one external resistor also we are connected there. In that case, what is the effective EMF as well as total resistance and current through resistor is equal to how much? Like that one question we are having. See that, what is that? Wrongly connected cells in series. Wrongly connected cells in series. So if n cells, each EMF is E, each cell EMF is equal to E, and internal resistance is smaller, each cell internal resistance is equal to smaller, are connected in series, and by mistake M cell are wrongly connected, M cells are wrongly connected to an external resistance, R, external resistance is capital R, then E effective is equal to how much? Total internal resistance is equal to how much? Third question is current through external resistor is. Okay, so that we are having n resistors, 1 2 3 so on n. Okay, all are series combination, positive negative positive negative positive negative. Each resistor, each cell EMF is equal to E, each cell internal resistor is equal to smaller. So ER n cells are there. By mistake, how many cells? M cells. M cells. So first this one, wrongly connected cells. Wrongly connected cells. All are having same EMF only, right? Same EMF mean what would be happen? This is the positive, this is the negative. So both are cancelled out. For example, 10 cells are there. 10 cells we should connect in series combination. We should connect in series combination. In this manner, how many cells are there? 10 cells are there. 10 cells we should connect a series combination. For example, one cell I connect a reverse. This EMF also same, this EMF also same. Then what would be? Both are cancelled out. Remaining cells, how many will be there? 1, 2, 3, 4, 5, 6 and 7 and 8 will come. Correct? That means one cell, if I connect in reverse mean, so remaining cells are how much? 8 only. For example, 2 cells I should connect in reverse order. Then what happened? So first cell this one, this one, this one. Total 4 cells will go. 4 cells will go. Correct? So how many cells? M cells are there. So 2 cells I connected reverse order. 2 cells I connect reverse order mean how many cells will go? 4. For example, 3 cells I connect reverse order. 3 cells I connect reverse order. Then what would be happen? So this one and this one and this one get cancelled. So total how many cells will go? 6 cells will be. That means 3 cells if I connect wrong mean. So how many cells will get damaged? 6. Correct? 2 cells mean 4 cells will get damaged. That means twice. So M cells mean how many cells will get damaged? 2 M cells. Correct? Generally. So M cells I connected wrongly mean how many cells can collapse? 2 M. 2 M. Correct? 4 cells mean 4 into 2. 6 cells mean 6 into 2. Like that, twice of the cells will get damaged. That means twice cells can collapse. Alright, remaining cells is equal to how much? Remaining cells EMF is equal to how much? That is my question. Right here. So E1, E2, E3, so on. And here 2 cells are M cells, not a 2 cells. This is the M cells. These are the N cells. N cells, total N cells. Total is N cells. In that M cells we should connect in series opposing order only. Therefore remaining cells how much will come? Remaining cells. So N dash is equal to N minus M. Correct? So total N cells are there. So remaining cell N minus M. What is the meaning of M? Wrongly connected cell. Correct? So now we will follow this one. What is that? Effective EMF is equal to for series combination N cells are there. Therefore, EMF is equal to what? N into E. N into E. Is that the series combination? M cells in series combination. How many cells will come? M into E. This M into E, which order? Reverse order. Reverse order means minus. Correct? Polarity change. Polarity change means formula, you know, E1 minus E2, right? That means N cells are connected in series combination in the same order. So M cells are connected in reverse order. So E, M, E. But here this is a N is not a total cell. Already M cells are over, right? This is the remaining cell. Remaining cell means we will consider as a N dash. We will consider as a N dash. So N dash. N dash is equal to how much? M minus M. Mean remaining cells. How many cells are connected reverse order? M cells. The remaining cells are how much? N minus M. N minus M. Correct? You have to remember that point. So effective EMF is equal to E dash is equal to, yes sir, E dash is equal to N dash into E minus M into E. This is the N minus M cells are in same order and M cells are in reverse order. Reverse order means minus. E is equal to E1 minus E2. Like that I told you, that is. So now N dash is equal to what? N minus M. N minus M into E minus M into E. Then E take common, right? E take common. Therefore what happened? N minus M and minus M is equal to how much will come? N minus M minus 2M into E. This is the E effective. Is the E effective. Finish. E effective. Next, total internal resistance. Total internal resistance. How many resistors will be there? N resistors. That means internal resistors are N. Internal resistors are N. So you can cut a reverse order also, same order also. Internal resistance does not change. R equal is equal to R1 plus R2 plus so on. Correct? N cells are there mean. So internal resistance is equal to R equivalent is equal to N into R only. N into R. Correct? All are having same internal resistance. And one external resistor will be there here. External resistor. Which combination? Series combination. Series combination means, so this one plus this one is equal to how much? R only. Therefore, series combination R plus N into R. R plus N into R. Then, current through external resistor. Current through external resistor. So, you know current through. What is the current formula? I is equal to E divided by R plus small r. Correct? R plus small r. But here E equivalent. E mean here E equivalent. R mean R equivalent. R else R effective. E effective. R effective how much? R effective N. This is the N minus 2M into E divided by R plus R equivalent how much? N into R. So this is the formula. I is equal to E dash by R plus NR. R plus NR. Right? R plus total resistance. E dash is equal to how much? N minus 2M into E divided by R plus NR. R plus NR. So previous also I want to give you this formula. Okay, that is my. So this question is over. So for example here small question. What is that here? How many resistors? How many cells are there? N cells are there. Okay, N cells are there. So on. Right. We should connect in series combination and one external resistor will be there. Series combination as well as one external resistor will be there. So this is the E, this is the R, E and R, E and R. Then E effective is equal to how much? This one. E effective mean E equal is equal to how much? E plus so on. E how many times? N times only na. Therefore what is the answer? N into E. Already I have given this one. N cells are connected series combination mean E equal is equal to N into E. R equal is equal to N into R. External resistance is equal to R only. Then I is equal to formula. What is I formula? E equivalent to by R plus R equivalent. Very important formula. They will ask question is the I only. So in the textbook, NCERT textbook, first 3.1, 3.2 related to this problem or this formula only. the inside textbook. First question and the second question, 3.1 and 3.2. So E equality is equal to how much? N into E divided by here. So R plus N into R. N into R. This is the effective resistance formula. Effective resistance. Only one cell will be there. One cell means just I is equal to E divided by R plus I, R plus R. R plus R. Correct? So here, and also you remember here, if M is equal to 0, wrongly connected cells are 0. If M is equal to 0, then what would happen? So 2 into 0, this total term becomes 0. Therefore, what would happen here? N into E divided by R plus N into R. If M is equal to 0. Same formula, right? M is equal to Ne by R plus NR. Okay? Right. So this is the cells are in series combination topic is over. Okay. Next, cells are in parallel combination. Right. So now cells are in parallel combination. Cells are in parallel combination. Right. I have to get two cells. First cell EMF is equal to E1. Second cell EMF is equal to E2. First cell internal resistance is equal to R1. Second cell internal resistance is equal to R2. We should connect in parallel combination. So E1 current is I1 I consider. E2 cell is given current is I2. E1 cell is given I1 current. E2 cell current is given I2. So I1 current is flowing like that, I2 current is going like there is a parallel combination, right? You see parallel combination currents are different, right? So at junction B1, at junction B1, the total current I is equal to I1 plus I2. That means this is the entering current, this is the leaving current again here. So you can assume that just you have to assume like that only. So circuit, closed circuit, now current is going like that. Is the entered and this is the leaving. Correct? Is the leaving from this part again entering this part only. That is. So the total current is I1 plus I2. That is the first point. Now second point. Second point is, so the potential difference between B1 and B2 for a cell E1, for first cell EMF is equal to how much? E1. Correct? Potential difference as usual. What is that? Potential difference is equal to, is a parallel combination. Potential difference same only na. Terminal potential difference I will consider, that is a V only. So that means VB1 minus VB2 both are same only. That means in this case potential difference is equal to same parallel combination. In parallel combination potential difference is equal to same. So in this direction I will consider VB1 minus VB2. That is the terminal potential difference I have given V directly. VB1 minus VB2 is equal to V. Right? So what is the formula? E1 minus I into R1. Correct? V1 is equal to V minus R1. Okay. Then now I want to I1. Therefore IR1 is equal to, so E1 minus V. Then I1 I want. Then I1 I want. This is current is I1, right? So through current there is I1. Therefore I1 is equal to E1 by R1 minus V by R1. Correct? That is I1 I got. Similarly, the potential difference between B1 and B2 for second cell. Second cell also same one. What is that? V is equal to E2 minus I2 R2. Therefore, I want to I2 directly. I2 is equal to E2 by R2 minus V by R2. Potentially same in parallel combination. Correct? This is the equation number 1. Is the equation number 2. This is the equation number 3. So now from 1 and 2 and 3. 1 and 2 and 3. Okay, I is equal to I1 plus I2 na. I1 value, I2 value you can substitute there only. Right? Okay, then what would be happen? We will see. So I is equal to I1 value. What is I1 value? E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. Now E terms write together. E1 by R1 plus E2 by R2 minus V take common 1 by R1 plus 1 by R2. This is the I. Now this one transfer this side, this I take that side. Therefore minus is becomes plus 1 by R1 plus 1 by R2 is equal to E1 by R1 plus E2 by R1 minus I. Now this one transfer to down only. So this is a multiplication and transfer that side. It becomes division. So E1 by R1 plus E2 by R2 minus I divided by 1 by R1 plus 1 by R2. Correct? So this is the 1 by R1 plus 1 by R2. So this is formula. Still this one we can write it. V is equal to E1 by R1 plus E2 by R2 divided by, okay, 1 by R1 plus 1 by R2. So this is the V minus I. So LCM is equal to what? R1 R2 divided by R1 plus R2. Correct? So LCM is R1 R2, R2 plus R1 goes to numerator is R1 R2. This one also you can do it numerator. Calculation. So you will get different answer. But I kept like that only. Alright, for a problems purpose only I have given like that one formula. Alright, this is the equation number 4. Then for equivalent cell, this one. So potential difference is equal to how much? Current is the I. Therefore, potential difference V is equal to E equivalent minus I into R equivalent is the equation number 5. So from 4 and 5 you have to compare. 4 and 5 you have to compare. What is that? E equivalent is equal to how much? E equivalent is equal to E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. Similarly, R equivalent is equal to R1 R2 divided by R1 plus R2. R1 plus R2. Alright? This is the two cells. If I have two cells, mean like that will be there. If I have n cells, then what is the formula, sir? Alright? Okay. Next. Right, still 5 mark question. This one very important 5 mark question. Still 5 mark purpose we will do like that. What is that? E equivalent is equal to, that one you have to observe once. So LCM E1 R2 plus E2 R1 divided by R1 R2 divided by, so R1 plus R2 divided by R1 into R2. This one get cancelled. Therefore, what will come here? E1 R2 plus E2 R1 divided by R1 plus R2. This is the E equivalent. Is a E equivalent. For two cells are doing very easy this one. For example, 3 cells are there, mean 3 cells. So that purpose only you have to use this formula. E equivalent is equal to, for 3 cells is there, mean, so E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Are you clear? 4 cells are there, mean E4 by R4 divided by 1 by 4. Correct? So 1 by R4. N cells are there. E n by R divided by so on. So what is that? 1 by Rn. 1 by Rn. Are you clear? So that is the series combination, parallel combination. N cells are there, mean n cells. For example, all are having same EMF, so that E by R plus so on, E by R. How many times? n times divided by, so 1 by r plus, 1 by r plus, so on, 1 by r, 1 by r, n times. So that top we can write what is that? N into E by R divided by here N by R only. R get cancelled, N get cancelled. Therefore, what happened? E only. So, very important conclusion this is. Very important conclusion. What is that? N cells are there. All are having same resistor, same EMF. We should connect in parallel combination. We should connect in parallel combination. Then E effective is equal to how much? E effective is equal to how much? E. Okay. So cells are, how many cells? N cells are, all are having same EMF. Then effective resistance is equal to, effective EMF is equal to how much in parallel combination? E effective is equal to E. For series combination, what is that? N into E. N into E. That means, do you want more EMF? Do you want more EMF? You will connect in series combination. Do you want less EMF? Mean you should connect in parallel combination. Correct? So for series combination, you will get large EMF. Alright? So small EMF mean you will get in parallel combination only. This is a very good, what is conclusion? Very important conclusion. N cells are there, we should connect in parallel combination. Right, man? So this is our small explanation. So next, here you can observe this one. N cells are there. N cells we should connect in series parallel combination. Then E effect is equal to how much? So that is similarly R1. So this is correct. So now E equivalent by R equivalent we will do. So therefore what happened here? E1 R2 plus E2 R1 divided by R1 plus R2 divided by, that is R1 R2 divided by R1 plus R2. So get cancelled. Correct? What will come here? E1 R2 plus E2 R1 divided by, this one R1 R2 separately we can write it. Right? R2 R2, R1 R1 get cancelled. Therefore E equivalent by R equivalent is equal to how much will come? E1 by R1 plus E2 by R2. Correct? So this is the final conclusion. E equivalent by R equivalent. Are you clear? So this is the formula. Up to here 5 mark question. E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2. Okay now? So now I will give you N cells are series parallel combination. What is the effective EMF? Right. So now N cells are there. Connected parallel combination. Each cell EMF is equal to E. Each cell internal resistance is equal to R. So connected parallel combination. Then E equivalent is equal to how much? E equivalent is equal to formula you know. E1 by R1 plus E2 by R2 plus so on E N by Rn. Correct? But all are having same EMF, right? Therefore what happened here? E1 E by R plus E by R plus E. How many times? N times. Divided by, so 1 by R plus so on 1 by R into N times. Right? Don't count this one. Okay. So later we will do that one. So now what is that here? N into E divided by R divided by, so R by N. So now, N by R. So R get cancelled, N get cancelled. Therefore E effective is equal to E. This is a conclusion of parallel combination. Very important this one. In parallel combination, so E effect is equal to A. E value does not change. Similarly, R equivalent is equal to how much? 1 by 1 by R1 this one. R equal is equal to R1 R2 divided by R1 plus R2 mean what is that? This is the 1 by R equal is equal to 1 by R1 plus 1 by R2 only na? Yes or no? So that 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus so on 1 by R. How many times? N times. Therefore, R equivalent is equal to N by R. So, R equivalent is equal to R by N. Same formula, R by N. So, that is the R equivalent formula. Right? For example, if I ask question, so now I want to current, sir. I want to current here, resistor will be there, R resistor. Okay, so now this is the I. Then I is equal to how much? Right? I is equal to how much? Right? So I is equal to, what is I is equal to? E equivalent divided by R plus R equivalent. R equivalent. Correct? N cells all are having same EMF. Therefore, E is equal to E, R is equal to R. This is the R by N. So that how much will come? N into R divided by N R plus R. Remember this one. In parallel combination is different, series combination is different. Correct? In series combination, what is the series combination? I is equal to N into E divided by R plus N into small r. This is the in series combination. But parallel combination formula, that is. Okay, that is the parallel combination. Still, only sir, we are having two cells only. We are having two cells. In that case, what is the current, sir? What is the current? We are having how many cells? Two cells only. We are having two cells. Just two cells. Therefore, I is equal to E equivalent by R plus R equivalent. Correct? So, this is E1 R2 plus E2 R1 divided by R1 plus R2 divided by this one. R is equal to R plus R equivalent to mean what is R equivalent? R1 R2 divided by R1 plus R2. R1 plus R2. So, E equivalent value you have to find it, R equivalent value you have to find it. Therefore, you will keep that value, you will get answer. Are you clear? So, this is the, so cells are in parallel, N cells are parallel combination. All concept over. Next, now here. So, if polarity of one cell is opposite, polarity of one cell is opposite. For example, this is the E1, this is the E2, this is the E3, but E2 is opposite. E2 is opposite. Then what is the equivalent EMF? Same formula. E equivalent is equal to E1 by R1 plus E2 by R2 plus E3 by R3. But here E2 is the opposite. Opposite means minus. Opposite means minus. So E1 by R1 minus E2 by R2 plus this one only. So same formula again. Right? For example, if R1 is equal to R2 is equal to R3 is equal to 2 ohms, 2 ohms, 2 ohms. 2 ohms. E1 is equal to how much? 10 volt. Okay, E2 is equal to 2 volt and E3 is equal to 4 volt. Then what is the answer? What is the answer? Alright. So now same formula we have to use. E1 is equal to how much? 10. R1 is equal to 2 minus E2 is equal to 2. R2 is equal to 2. E3 is equal to 4. R3 is equal to 2. 1 by R1, 1 by 2 plus 1 by 2 plus 1 by 2. So 2 1 0 2 get cancelled. Correct? Or else LCM will also get take, no problem. LCM is equal to how much? 2. LCM is equal to 2. Correct? Then so 10 minus 2. 10 minus 4. How much will come? Plus 2. Plus 2 plus 10, 12. Correct? So 2 get cancelled. So this is the 1 by 2 plus 1 by 3, 3 by 2. So 2 1 by 3. That is equal to 3 ones, 3 fours. 4 volt. That is the E equivalent. Next, R equivalent. R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. So that 1 by, how much? LCM is 2, 1 plus 1 plus 3. 3 by 2. If I want, I mean I is equal to, so direct. I is equal to formula E equivalent by R plus R equivalent. R is not given there, neglect only. Not given, right? Neglect. So E equivalent is equal to how much? 4. R equivalent is equal to 3 by 2 goes to numerator. Therefore, 8 by 3 amperes. I is equal to 8 by 3 amperes. Are you clear? So this is the cells are in parallel combination. Last concept is mixed grouping of cells. Mixed grouping of cells. Right, last topic is mixed grouping of cells. Mixed grouping of cells mean here we are having n cells. We are having n cells. See that if cells of EMF is E are arranged in m rows. How many rows? M rows. Connected in parallel. M rows connected in parallel such that each row contains n cells. Each row contains n cells. Then, so number of cells, mean total number of cells is equal to total circuit. In the circuit, total number of cells is equal to how much? Next one, A equivalent is equal to how much? Next one, R equivalent is equal to how much? Then I is equal to how much? E equivalent, R equivalent, if you know, through R, current is equal to how much? Then condition for I to be maximum. So I is becomes maximum. What is the condition? Then I max is equal to how much? I max is equal to how much? Okay, right. So now we are arranging like that. What is that? So how many cells are there? N cells. How many rows are there? M rows. So this is the number of rows. This is the number of rows. How many rows are there? M rows are there. Each row, it contains n cells. That n cells are connected in series combination. Each cell connected in this direction, series combination. Series combination. Like that, how many cells are there? How many rows are there? M rows are there. How many rows? M. Each row, how many cells? N cells. So therefore, total cells is equal to M into N. Correct? M into N. Each row cells is N. N cells are there. How many rows are there? M rows are there. Therefore, M into N is nothing but number of cells. Total number of cells. That is the first question answer. So, now total cells is equal to N into M. N into M. That's why Mn. Very important question this is. Number of cells. Mn. Mn is the number of cells. Do you want Mn? So, number of cells by N. Number of cells by N. So, you will get M only. How many rows? How many rows you want to mean? Right? Each row, how many cells are there? N cells are there. That is the first one. Right, second one. What is second one? E equivalent is equal to how much? Right. So, series combination only. Na? So, this is series combination. E. So, this is the total. How much will come? En will come. This is the En. Resultant is what? En into E. Here also N into E. Here also N into E. Here also N into E. How many rows are parallel? That means NE is the parallel combination. Correct? So, NE. What combination? Parallel combination. How many rows like that? M rows are there. M rows. Right? In parallel combination, what is the effective resistance? In parallel combination, effective resistance is equal to just E only. Na? That means E is there mean. So that is the value is E only. Instead of E, what should be there here? N into E will be there. Therefore, equivalent resistance is equal to E equal to N into E. N into E. Correct? Instead of E, so first cell, second cell, third cell, like that. We are connected parallel combination made. So E equivalent is equal to E. In parallel combination. So, instead of E, what should be there here? N into E. N into E, NE, we should arrange it in the parallel combination. Therefore, E equivalent is equal to how much? N into E. N into E. Similarly, here, parallel combination also. So, many one R will be there. Therefore, what will come here? N into R. N into R, N into R, N into R, N into R, so on. N into R will come. Correct? Parallel combination. NR. In parallel combination formula, you know. So this is the R, this is the R, this is the R, this is the R. 1, 2, 3, 4. So R equivalent is equal to how much? R by N only. Na? R by N. 1, 2, 3, 4 mean R by 4. R by 4. Each resistance is equal to small r. Each cell is having resistance is equal to small r. Parallel combination formula, R is equal to R by N. R is the each resistance value, each internal resistance value, therefore R by N. Correct? So this value. Now, in this value is equal to how much here right now? In parallel combination. So this is the parallel combination. This is the, so NR, like that. How many parallel combinations are there? M rows are there. M rows. That means M. So, correct? NR, so on. How many will be there? So M will be the total number of resistors is M. Therefore, R equivalent is equal to, okay, R dash by N. R dash by N dash. Here R dash is equal to how much? N into R. N dash is equal to M. Number of rows. Number of rows. Number of resistors. Number of resistors. Correct? Number of resistors is equal to M will be. Therefore, R is equal to NR by M. NR by M. That is the R equivalent. R equivalent. NR by M. R by N. General formula. R by N. Instead of R, what should be there? NR. Instead of N, what should be there? How many rows? M rows. Therefore, M. Here, 1, 2, 3, 4. 4 rows are there. Therefore, 4. Here, how many rows are there? M rows will be there. Therefore, M. Parallel combination, right? Same. Resistance also same. Internal resistance also same. Right. Next, fourth question. So, fourth question, what is that? I is equal to what? So, I formula. E equivalent by R plus R equivalent. Formula you know, right? R equivalent by E equivalent by R plus E equivalent. R equivalent. E equivalent is equal to how much? N into E. N into E. Okay. R. This is the R. Later I will give M. Okay. R equivalent is equal to NR by M. NR by M. So M goes to numerator. M into R. MR will come. Like that this formula will come. This formula in this manner will be there. Right? So finish. This is the I through R. Very, very important. Next, last question, fifth question. What is that? What is the condition for maximum current? That means this is the current formula. I is equal to Mn E by Mr plus Nr will be there. Now I want to, I is becomes to maximum. I max is required. I max is required means this denominator value is less only required. Correct? This value is less mean what would be happen? I value is becomes to maximum. I value is becomes maximum. Correct, Ranga? Yes. So denominator value is less mean I value is becomes to maximum. I value becomes maximum. So that what is the condition? Mr plus Nr is equal to less value is required. Less value required means, so we want to do subtraction. Mr minus Nr we want to. Generally, correct only na? That this value decrease means here minus symbol is required. That minus symbol purpose we have to go this one only. What is that condition? If Mr plus Nr is equal to minimum, then I is becomes maximum. So this Mr plus Nr I written like that. See that. What is that? Mr plus Nr is equal to root over Mr minus root over Nr whole square. A minus B whole square plus 2AB. 2AB. Same formula only, right? A plus B, A minus B whole square means A square plus B square minus 2AB. Minus 2AB. 2AB means 2 root over Mn minus R. Get cancelled. Therefore, same formula will come, right? Correct? Therefore, now I will consider this value. So, root over Mr minus root over Nr is equal to minimum mean 0. Minimum means 0. Therefore, this is the condition. Is equal to minimum. Is equal to minimum. 0 in that sense minimum. So that this one transfer that side. So, root over Mr is equal to root over Nr. Square get cancelled. Therefore, R is equal to Nr by M. Or else Nr is equal to Mr. Any formula you have to use in this case. In that case, I is becomes maximum. Therefore, I max is equal to MNE. MNE divided by, so instead of MR, I will consider, what is that? Instead of, okay, or else instead of MR, I took there NR first. Okay, no problem. So this one transfer that side. So what happened? Rm is equal to Nr. Correct? Instead of Mr, I took Nr. Nr plus Nr, 2Nr. So Nn get cancelled. Therefore, Me by 2R. Small r is a very small resistance, right? Correct? Therefore, I max is equal to Me by 2R. Or else, instead of Nr, if I consider Mr, so that 2Mr will come. So get cancelled. Therefore, Ne by 2R. This is the maximum. That's it. This is the cells are in series combination, parallel combination concept is over. Next topic is the Wheatstone bridge, 5-mark question, and potentiometer, meter bridge and potentiometer. That's it. Right? Okay. So you can listen carefully these concepts. Very, very important. Next session I will give you Wheatstone bridge as well as some problems based on Kirchhoff laws also. Right? Okay. Thank you to one. Thank you.